Okay, so hello everyone. Can you hear us? We are now in the lab.
Yes, we can.
And you can see that I'm holding a camera. I guess you can see multiple cameras, but
Right now we're seeing the main display is the GUI, the GUI.
okay, so maybe we can stop sharing. Take off the camera there. Yeah. Okay, so now I assume that you see the rig.
Yeah.
Yeah.
Yep.
So we have now spent the time to prepare for the drilling operations. But before we start, we can go through the different components on the rig, so you can see them physically. So yeah, I will just start. On top here, we have the top drive motor. Now the hoisting motor that applies rotation to the ball screw, as you can see here. In addition, on the ball screw, we have the load cell that measures how much weight on bit we apply when we are drilling. The second motor on the rig is the top drive, as you can see here. It is connected to a drill track and also to the rod that is transferring rotation and torque to the drill bit. Here is our rotary table or azimuth motor that orients the drill pipe when we are drilling. Further down, we have this blue component here, which is the torque sensor that measures how much torque we apply to the drill string while we are changing the orientation of the drill pipe. Next, we have the hydraulic swivel that allows drilling fluid, in our case water, to enter the system. It goes in here and further to the drill pipe. And yeah, this is the aluminum drill pipe that we use. Furthermore, we have a upper stabilizer here on the drill floor, which is further. Furthermore, we have the lower riser here that provides stability to the BHA while we are drilling. We also have the BHA, which you cannot see now because it's covered with the diverter that we implemented this year. So the BHA is inside here. So unfortunately, you cannot see that live. We have already placed the rock inside the drilling cabinet here. The diverter is connected to a hose, which allows the cuttings to be diverted away in a safe manner, so it doesn't accumulate on the rock surface or on the floor. So that was a brief mechanical explanation of the rig. Are there any questions so far?
To handle the rock, do you just roll the rig over the rock?
No, we have a trolley here, as you can see. So we place the rock sample with that one to position it.
Okay.
So as you can see, it's a homemade wooden box, which allows to fit the trolley in here. So if there are not any questions, we will go over.
Wait, can you describe the control system and the different boxes?
That was my next plan, to go through the control system. So we can first go through the low-level system that is responsible for the autonomous operation. As you can see, we have different parameters here that we can monitor while drilling. The first one is the top drive torque. Second one is weight on bit from the load cell. And we also see how much azimuth torque that we are applying to the drill pipe. We also have a measure of the ROP while drilling, the rotational velocity of the azimuth motor, and also the top drive RPM. And the exact values are shown here for the torque, different torques that we have in the system. And we have some green lights here that will turn red if something goes wrong, or we go outside the operational limits. Furthermore, we have the autonomous operation, different states here. We have the vertical state, we have the target intersection state, we have rock exit detection and also completed. So when we start the system, we can just press start on the button and the system will do the whole operation by itself. So that is the low-level system. We also have another computer, which is the high level, that is responsible for the position of the bit downhole. I don't know if you can see the planned trajectory that we have generated with the targets that you gave us with Dubin's curves. So that is the planned trajectory. We are not using inches, but we have centimeters on the different axes here.
Okay. What are the electrical boxes that are to your right?
You mean this one? We have this is the high level computer inside. So it's just a computer.
Okay.
Yeah. And we also have the electrical cabinet here and the emergency stop button here.
Okay.
So if you have any questions, please let us know and we will try to answer them. And this rotation set point is the MPC controller that generates the set point in order to steer the bit towards the target.
I may have overseen during your presentation, but do you have any pressure measurement for the fluid which is circulated into the drill string?
No, we don't have any pressure measurements since we are only using water from the tap.
Right.
Yeah.
Okay.
So,
thank you.
Yeah.
Okay. Let's go to work. We're ready when you are.
So if you don't have any more questions, we will just prepare for the actual.
I have one more question. Do you show the inclination or the position, the current position on the screen?
Yes.
I see that there is a graph. Yeah, okay. Then you
So
have
we
the
have
position.
X, Y, and Z.
Right.
So the actual estimated or drill trajectory will show up on this graph with the red line. And we also have inclination measurement here and azimuth.
And do you have a distance compared to the plan?
No, we tried to implement it yesterday, but we experienced some problems when we tried to use it in the graphical user interface here. So it was probably because of it took too much computational power for the system, but we didn't have time to figure out the problem.
No problem. No problem.
Hey, one more question. What is 000? The top of the rock?
Yes, the rock surface is 000.
Got it. Okay.
So we prior to the competition, we drilled a pilot hole according to the guidelines of 1 inch. But the definition of the zero definition is on the top of the rock. Yeah.
And the 0 for the azimuth, since you are not measuring the magnetic field, so is it a particular direction compared to the rock?
We have assumed that the azimuth is equal to the orientation of the azimuth system. So if we are orienting, for example, 10 degrees, we just put the azimuth equal 10 degrees. So that is, of course, an assumption that will impact the estimation of the drill bit's position. But that's what we ended up with when the magnetic field didn't work. Okay, so then I think we will need 3 or 4 minutes just to do the final preparations before the drilling operation starts. And yeah, today we will be drilling towards the targets that you have provided. It's in both X and Y direction. So we will start first we will drill the vertical section by going back and forth, as we have explained earlier, and then we will kick off, or before we kick off, we will orient the bend set towards the targets. Then we will kick off and steer the bit towards the targets, hopefully.
I have a question. Will you be able from time to time to share one of these screens with the graphical user interfaces?
Yes, we will be sharing the high level one, and we will try with a webcam to display the low level, which is down here. So I suggest that you can choose between the different camera views. We also have a camera that shows the drilling system. So for you, it's it's your choice which camera or which screen you want to see at all times.
Maybe it can be good if the jury could just send comments in the chat. So which camera
so
they
we
want.
will have one operator that will monitor the chat at all times. So yeah, we will try to answer the questions that arise during the drilling.
Yeah, because during drilling we will not be able to listen to you because the system is noisy. So we will use hearing protection. So if you have any comments or any questions, please write it on the chat. We will try to answer them. There will be 2 people completely dedicated to drilling. One will be the operator and the other one will be the assistant. And the other 2, we will be attentive to your questions. Remember that everything is going to be completely autonomous. So we will be fully on surveillance mode. There's going to be times when it's going to stop to take the surveys every 5 centimeters. If we can try to answer there, but we would like to write down the questions, and if we cannot answer you in the text, we will do it after the drilling is done.
Sounds good.
Okay, so then we need 3 minutes to do the final preparations, and then we will just start the drilling session. Okay. See you in 3 minutes.
Very good.
Hello, can you hear me?
Yes.
Yes.
Okay, so we are ready to start drilling, okay? Now we have reached the kickoff point. The system will now orient towards the targets and resume drilling.
So we have now approached the first service stations. The system will take the measurements, and we will continue drilling soon. No, we are currently on 0.7 degrees on the inclination.
That is due to the noise while we are drilling. That's why the actual measurements are taken during surveys. Can you explain again, Fred, what do you want, please? You want us to share not the first but the second monitor?
To the left, Michaela. To your left. To the graph. Yeah, right there.
Every 5 centimeters. Yes.
Hello, this is a sample of the returns. So you can see it has very few. They're very, very fine.
Okay, so there the operation stopped automatically. So we are done with the drilling of this well. Yeah.
What does your final survey show? Is that what's shown on the graph? Your deviation from plan?
Yeah, so the final survey shows 6.6 on displacement on the x-axis and 5.6 displacement on the y-axis. I don't know what that is converted to. This is in centimeters.
Got it.
So as you can see, we had a small deviation in the end.
This is due to the between 50 and 60 centimeters is no surveys. So
Yeah.
if you added one more surveys, probably will get better.
Yeah, so after 55 centimeters TVD, we don't take any more surveys, so we are just relying on the model. So that is probably that is probably the reason why we have this deviation. So with one more survey, we could probably have been closer to the final target.
Got it. Hey, but congratulations, your rig worked. You were able to drill and didn't break anything.
Thank you very much.
This one? Turn around.
Yeah, so I don't know if there are any final questions or if this is the end.
I have a question, guys. So if you rely only on the static survey readings for inclination, azimuth, etc., that means that both the path and any control action is decided at the survey, and you keep it constant until the next survey. Is that correct?
Can you repeat, please?
Yeah, we had some technical issues.
We're changing to the main computer again.
Yes, yes. So if you rely on the readings from the static survey, you know, for inclination, azimuth, etc., to calculate the well path, as well as any corrections that you need to make, I assume that the azimuth setting or the direction that you are trying to go, or all that is staying constant until the next survey. Is that correct?
We have our orientation velocity model in between the surveys that we have some variables to estimate what the roll and pitch is between the surveys.
Yeah, so we feed the measurements of the surveys into this model.
Okay.
And
okay.
we also have this MPC model that tries to get the drill bit back on track on the plan.
Yeah. Okay, I follow you. That's where the digital twin comes in.
Yeah.
And once you get the next actual survey, do you go back and do any update to the model, or the model stays the same?
We use the same model, but of course with the new values from
Sure.
from
Okay.
sensor card. Yeah.
Okay. Very good. Thank you.
Hey, just to clarify that question. So at each survey, you are calibrating your digital model, and then between surveys, are you using the digital model to make corrections?
Mm-hmm.
Yes, we are. Yeah. So yeah, the model is updated, and the MPC controller tells the system how much the azimuth rotation should be in order to get back on track.
That's interesting. So I thought this was equivalent to a typical mud motor drilling where all you have is survey and there's no model, but you are using the model to correct in between surveys. Okay.
So at point early when we started drilling early on this semester, we experienced that the sensor card provided wrong values, so we went in the opposite direction. So there was a mistake in the definition of the different directions. So yeah.
Very impressive what you have, guys. Congratulations.
Thank you very much.
Thank you.
Do you actually have downhole azimuth and inclination?
The inclination, yeah, but the azimuth is.
I understand the magnetic aspect, but do you actually have the data that even though it's noisy and may not be right, do you have that data?
Yeah, I think we have them saved. So, but it's a bit hard to get it up right now with all.
Okay, it's okay. The other question is, on your display, you have some buttons that are green and yellow, which seem to be like a drilling state. Can you show those for a moment?
Yeah. So I assume you refer to the different states that we have here.
Yeah, I didn't quite follow how you determine those states.
So yeah, how we determine them. Jale, can you answer?
Yeah. So the first state is the drill vertical. That is like for the pivot roll into 10 centimeter or 4 inches. The next one is target intersection. So in the beginning of target intersection is like it corrects where the azimuth should start based on the target points. It calculates what angle the azimuth should start about, and then the target intersection it tries to like steer against the target points to reach them. On the next drilling towards exit is when it came. It's like 10 centimeters from the rock exit. Then it's activated, and then it's like weight and bit and different parameters changes. And then when it's very close to rock exit detection, the state that activates and is lower weight and bit and reduce everything. And I think it's drilled some few centimeters, and then it's complete. So it's like rock detection is just like calming down the system, and then it's completed.
Yeah.
And then we have like weight and fusion input. That is if you stop the system halfway or in the middle of the session, then you can like, then it will show up, and unexpected termination if something unexpected happens.
So we just pressed start in the very beginning, and it went through all the different states until the completed state, and it stopped automatically in the end. We didn't press anything in the system.
Not even the service, nothing. Yeah. I mean, the system's been completely autonomous.
Only one click on,
But this state determination, is this based on measured depth compared to planned well path?
Yeah, drill vertically is determined based on 10 centimeters or 4 inches. So that is the first state. And then it goes towards intersecting the targets.
Yeah.
Yeah.
But you're really comparing measured depth to your planned depths for these different events? Okay, great. That's perfect.
Yes. Yes.
Okay.
Go ahead, Eric.
Yes, first of all, really congratulations. That was very impressive demonstration. So, but I'm just wondering about the management of the bend orientation. Do you consider that as an azimuth or as a tool face? Because at the end, when you were too high on the inclination, I would have almost expected that it would have turned 180 degrees to try to drop back actually to the right inclination. Do you have any comment on why the algorithm didn't pick up that possibility and continue to keep the azimuth or the orientation of the bend in the same direction?
Yeah, we studied that option, and we know that it since a fixed bend up, if we change as long as we are building up, if we change the orientation or changing the azimuth, it will do a change also in the build-up rate. So you need to play between the build-up rate and the turn rate. We looked through that, but we didn't have time to completely apply that part. But yeah, we went through that in the technical part and in the theoretical part. Yeah.
Okay, yeah.
Okay, one maybe a follow-up thing to do is to, if there's a way to look at the actual trajectory, maybe you cut open the rock and compare what your digital twin was recommending versus what actually it looks like between survey stations.
Yeah, well,
Yeah.
we do
Interesting.
that.
Yeah, we looked at the possibility, but here at the Institute, we didn't have a large enough saw blade to cut through the rock.
We looked
Well,
at the endpoint, though,
Yeah.
when we
Yeah.
drilled.
Yeah.
What we do is that we drill out the rock. So we calculate where we have to start on the rock and where we should go out in order to know that our system is actually following the well path that we're seeing, because here we cannot see anything. Other teams try to do survey tools like a gyro or a caliper, but it's been in this size it's challenging to do stuff like that. So the only calibration point we're doing is actually exiting the rock either on the sides or on the bottom of the rock.
Yeah, so we kept the azimuth fixed, and then we were just building until 30 degrees, and we measured a horizontal displacement of around 11, 12.
12,
Yeah.
13
Yeah.
points.
Well,
We measured 12
although-
centimeters, and it should be 13 in order to reach 30 degrees inclination.
Just an idea, could you take your current BHA and take multiple lot more survey samples instead of just 5 centimeters, maybe every 2 centimeters?
Yeah,
It's definitely a possibility.
that's
You just
Yep.
can go back in and do it, right? Hopefully BHA won't get stuck when you're doing it.
Yeah.
This is nice. Good job, team.
Thank you.
Thank you.
One of the things that I'd like to see is a photo taken from the top after you disassemble the rig and move it away from the rock, and just see, is there any spiraling in there of concern?
Yeah. The vertical part, I mean, it's not so spiral, but you can actually see it's a little off gauge, of course, because we're drilling with an eccentric bit.
Yep.
So it's a little off gauge. Yeah, we can show you that.
Yeah. Well, you're going to get a paper out of this. So that's why you need those photos.
Oh yeah.
Yeah.
Okay. Yeah, we'll send them.
Yeah, it's
Yeah.
a bit complicated to get out the drill string right now.
No, I
But
understand.
we can do it if you want, but
Yeah, if you
takes
want.
some time.
Yeah, if you want, we can do it. But since we have done, as we told you, we need to take everything manually. So we first need to secure the drill, then disconnect everything, then take it out, and then we can show it to you. So
Yeah, just email a picture later.
okay.
Yeah.
Yep, perfect.
We have some pre-drill or some wells we drilled before that we can show you if you want.
Luis, I have a question. You cannot pull it out while rotating. Basically, have a slow rotation and kind of rim your way out instead of pulling it manually.
We've tried that, and if we know the tortuosity is not that bad, we do it like that. We do rimming, and we flow as well to make it easier. But when it's highly inclinated or we know it's highly tortuous, and we start pulling back and we feel a little overpull, then we stop and do it manually. Yeah. That's the normal procedure we do.
But most of the times it works, but sometimes we get stuck and we don't want to risk any connections.
Yes.
So since you drill many wells or many holes to test your system, what is the highest inclination you have got to? What is the maximum build-up and drop-off rate that you have used? Do you have any indications about that?
Yeah, so we have always started to kick off after the kickoff point at 4 inches. So then we have been able to reach around 29, 30 degrees maximum.
I mean, if you drill 60 and 10 of the first 10 are straight line, so you have 50 centimeters and you go from 0 to 29 degrees.
Yes,
so
it's impressive.
It's impressive.
Rate 56 degrees per meter.
Correct. 56 degrees per meter is the build-up rate of our bends up.
Well, I can say this. I think you guys have done a tremendous job. You and your predecessors built a good rig. You made it better. The first thing this morning is I was very impressed with the research that you've done, where you have run into problems, you have dealt with them, and you've secured help from people that can help you, and you've learned from it. And what's interesting is the entire team is understands all of the issues. So each of you have specific areas, but it's obvious that all of you as a team have learned a lot. And I just compliment you for doing a tremendous job this year.
Thank you.
Thank you very much.
Thank you.
Yeah, the multidisciplinarity in the team is a key project.
Yeah, because you bring ideas that, for example, I will never thought about it, but then they think of that. So yeah, that's amazing. It's amazing.
Yeah, you guys have done a great job.
Thank you.
I'm going to go back and look and try to understand what our rate of penetration was in 2015, 2016. We drilled these wells in hours, not minutes. You guys are doing just a great job.
Yeah. The next year, ask them to find oil.
Have here some like a sample, so you can see the size of the cuttings is just it's pure dust. That's why we don't have problems with the. I think our bait is giving an amazing performance. So
That is.
we don't have problems with cuttings, with hydraulics, with back off, the like problems you have in real life. Here it just goes right like butter. So that's a very good job from the point of view of the design of the bit.
Yeah, but we're going to give you some different rocks in the future.
Bring them.
Your life has gotten too easy.
Yeah, it would be fun to try different materials. Here, since you gave us like a range of UCS for the compressive strength that we might get on the day of the competition, we tested against different USC from our cements as well. So we were trying to get as prepared as we could for that.
So this one is around 4,000 PSI, I think.
Correct. Yes.
One that
You're gonna have to drill that rubber mat again like we did before.
Fred, I still remember this horrible rock that you sent us in 2017. Different types of concrete, asphalt, kitchen tiles, rubber.
Yeah.
You were having fun making it.
Aaron called me evil. But everybody could handle it. It was really impressive. No, you guys have done a tremendous job. You should be very proud.
Thank you.
Thank you.
It's been really fun. That's the most important
Great
part.
project to be part of, definitely.
So is there any part of the project which is part of the curriculum that you have in your course? Or is it only outside the courses that you have?
No, so this has been our final master thesis project. So yeah, we have in a thesis as well.
Right. Yeah.
So yeah, in combination with that thesis.
I think we can also thank Alexei to put together all the necessary things which are behind your team, and of course your team is really excellent. But I think there is a extremely good synergies between NTNU and the students.
Yeah.
Thank you for that. I basically wish to think that our role was larger, but in general, we in fact we had a very autonomous team. So it was just we had a few survey points every month, well, closer to the competition a bit more frequently. But the team was very autonomous, and I was very impressed myself today, hearing everything what they have done, what they have researched to achieve to come when they come to this point. Very well done.
Thank you.
Thank you.
And has all of you got a job already, or?
Yes.
Yes.
Oh, that's a pity.
So we are going to be based in Trondheim, Stavanger, and Bergen.
Yeah, we're gonna stay here.
Congratulations.
Thank you.
Thank you very much.
Well, when you're unhappy, you can call Eric.
I have a couple of PhD positions which are opening, so if you want to test yourself, so.
Thanks.
I think it is the team, not the drilling rig, that is the main product of this project. And I'm very proud of this product.
So you have completely new team every year.
Yes.
For the competition. Okay.
Yes.
No, I mean, nobody stays longer than 1 year.
No.
Wow.
And it's actually the transition from one team to another team is something that can be improved over a year or over years, because there is still kind of a gap in knowledge transition
Sure.
from
sure.
one year to another year.
I think you are doing all teams have been doing a good job documenting what they are doing and passing as much as possible, that knowledge forward,
Yeah,
Yes.
yeah, we have a lot of documents to go through, but it's the actual experience with the drilling rig that you learn from. So yeah, all the teams have to go through the same procedure when they start in the very beginning of the year. So,
Yeah. Interesting. Very good.
And also all the teams are pushed to start drilling as early as possible, because no digital twin can substitute the actual drilling experience.
Yeah.
That's actually a really good thing to do. You drill faster, you'll know what doesn't work.
That's where you learn everything, like
Yeah.
all the things we've experienced as well.
Yeah.
Where we've captured and been the more fun end, you can say.
Right, we are ready to close.
I think so. Unless anybody else has anything else, I'm done.
I just maybe want at the very end to thank the team for their tremendous job. It was a real pleasure to work with you. You're one of the most autonomous teams that we had. Well, most of our teams are very autonomous, but you are on the high level in this spectrum. So I wish you first of all, fantastic summer holidays. You have deserved them. I wish you excellent careers, good start, and then excellent continuation and high growth in your future. So good luck.
Remember to ask them for donations back to NTNU, Alexei.
we also want to thank you, Alexei, for providing us support, and we also want to thank Fred Florence and the judges for organizing this competition and making this possible.
Well, I'll say it's not me. I'm the one that stirs the pot. But the people that really know things are the ones that are contributing. Aaron, for example, Mike has just taken a new job starting on Monday, or he would have been here as a judge. And he's had huge influence over what we've done in the directional aspects of this. And then there's so many other people that have contributed over the years. I started writing a history of it and realized how many dozens and dozens of people that's really made a big difference for the program. So I will ask you to try to stay in touch. We'd like to form an alumni association so that you can get to know where your team members, your competitors, maybe they've ended up in another place that you might. It's a small industry. You'll probably cross paths somewhere.
Yeah.
Fred, maybe we need to think about organizing Drillbotics conference. Just a gathering of all the graduates of the Drillbotics competition.
Yeah.
There will be quite a number.
Yeah, that sounds fun.
Yeah.
All right. Good idea. All right. Thank you, everybody. Have a good summer.
Thank you.
Thank
you,
you.
everybody.
Take care.
Have a
Thank
great
you.
Bye.
Congratulations again.
Thanks for the great show. Thank you.
Bye-bye.
Bye-bye.
Bye.